Hello everyone and welcome to the 9th lecture. Today will be our first darts lecture, so we will have a look at how we can implement a physically correct flying dart and thus have a look at collisions, physics, and a physics handle. So without further ado, let's head right into it. As always, let's have a quick look at our current project progress. What you can see here is that we've already finished the console chess part, that's down here, and we also finished our 3D chess, which is the chess party part up here, where we build our fully functional 3D chess. And thus today we will advance to the physics and projectiles section, especially the physics-based dart handle today. Let's quickly check how our dartboard currently looks inside the engine. You can see I have already opened it up on my screen and there is something overlapping with our darts, so let's get quickly rid of that by enabling the burger menu up here and ticking game view so we can see how it actually looks in game. And now let's quickly jump forward to our darts, and you can see we have two different colors here. The one on the left will be part of this lecture. That will be how we can handle the darts physics-based, whereas the other one is part of the next lecture where I want to show you how you can do that spawning a projectile instead. Of course, we also need to implement the throwing logic for the dart, and that will be done inside our living room player. So we can go into our content drawer down here. And I've already opened it up, but let's quickly do it together. So we are inside the content folder. Then we go to living room in this case. And inside the living rooms folder, we have the blueprints folder. Inside the blueprints folder, we then have our living room character. And let's quickly double click onto that. And you can see there are two parts which actually refer to the color of our darts. Here we have the dart logic which we will implement today together. And this will be part of the next lecture down here, where I want to show you how you can do that projectile-based. We also have our darts, of course. They are not inside the living room folder, but instead inside the content folder, interactive media, then darts, and now we have our blueprints in here. You can also see I added some special parts in here, such as the arrow rifle and some animation, but that will be part of the next lecture, so let's quickly jump over there. Inside the blueprints folder, we then have our darts. So this is how our dart looks like inside the viewport. Let's quickly scroll here and you can see this is our dart mesh and we have a collider around it. So whenever this collider hits something, the dart will then be stuck. At the moment, this is not the case. And of course, we can't pick up the dart yet because we haven't implemented anything that includes a logic. And we will do that together in a second. So that's the Dart parent blueprint. And now we have two child classes. You can have a look at them. If you just create a new child blueprint class, you would create one more of them. But those two are already child classes. We can see that again by having a look at the parent class, which refers to our Dart here. Then we have the Dart cabinet. Nothing special about that except for two colliders. So if we scroll in a little, you can see on the right side, I added a collider. So we can actually not throw through there. And here we have our dartboard, which is separated. Yeah, which is a separated mesh instead of being combined together with the dartboard itself. Then we have also the darts physics here. So let's quickly click onto that. You can see it doesn't open up the full blueprint editor. So let's quickly do that. And you can see inside the viewport, I did nothing else except for changing the material here, which you can see on the right side. So I just set the material of the hold here to red instead of what it was before. Let me see. Okay, it was black. So now it's red. And the same we did for the dart projectile, except we have there one more component, and that's the projectile movement. But yeah, that's everything we added here, and we have some dart physics. So in this dart physics, we have the collider, and this collider, you can see it here, has something enabled. In our case, namely simulate physics, and we also have a specific part of the collision enabled. And this collision preset actually for both of them took me, I don't know, like 8 to 32 hours to get it exactly right, because when you play darts, you have, of course, to be able to detect exactly where the dart has hit the target, and it shouldn't be stuck, like, for example, at the tip already, and it should also not fly through something, it should bounce from the wall, and so on. So the collision preset here was pretty tricky. First of all, I enabled simulate physics, and then we have something in the advanced section that shouldn't be anything different than normally, but inside the collision, I had to change something, and that is both generate hit events and generate overlap events. So hit means just you hit something, overlap means you are actually overlapping something, which would look like this, for example. And then we have the advanced part inside the collision. So you can see I enabled the physics actor preset, which allows me to set all of that to be blocked. And then we have inside the advanced section the CCD. And if I hover over it, you can see it's the continuous collision detection. So we have a very, very detailed and good working collision. So that's way less efficient than just a normal collision check, but instead it can detect exactly where the dart has been hitting the dartboard. So that's what I enabled in here for the dart physics. And let's get to the actual coding part, because now you know how the dart inside here is built up. And now we have to find out how we can actually throw it after we picked it up. Before we can start with the interactive part, we have to get rid of the problem that we are not able to give any inputs towards these darts. And to do so, we have, first of all, in our content drawer, inside the content folder, this living room folder. And in this living room folder, we have the blueprints folder. And if we now click onto the living room character, it opens up for us, and you can see there are those two sections I already mentioned, and the red one will be relevant for us for this lecture. But there is no input included yet. And we can do that by going back to the content drawer. And now we go to interactive media instead of living room. If we now go on to the darts section, and then there is an input folder for us. And inside this input folder, we have two defined actions and one input mapping context. You can see that by hovering over it. And let's quickly check what it does for us. So first of all, the grabbing logic is implemented inside the IA underline grab. And you can see there's nothing special in here except for one thing, and that's the relevant one when you define input action. So inside the triggers, we have the trigger to be pressed. We have also down, hold and release, pulse, released, and so on. But we just need to press something. It doesn't matter which one. That will be then done inside the input mapping context. But we define if the trigger is pressed, then this action will be called. The next part which we have is our throwing logic. So let's go on to the throw. Here you can see we have two triggers. We have pressed and we have released. And as you can see, it's the same menu as before. So that's how we could just change it. And inside the input mapping context, we now define what should trigger our input actions. And you can see I already added the input action grab here. So if I go into here, you can see I can just select whatever input action I want. And those are all available inside my project. And if we now click onto this arrow here, you can see I defined the right mouse button to be used once we press the right mouse button, the input action grab will be triggered. Then we have the input action throw, and as you can see, that's done on the left mouse button. And that's just how you can define what key you want to have pressed to actually trigger this input action. We also have the look around. You can see that's the mouse, X, Y to D axis. We have the IA move, so we can press WASD. We can also use up, down, right, left, and we also have a gamepad involved here. And inside the input action, we have the spacebar where we can jump around. And that's just for our player to be moved inside our map. Those two are custom, and you can just add one more by clicking onto the plus here. Then you can select what input action you want to have, and that's just how you could add that. If you want to adjust the button you want to press, you can either click here, you already know that, then you can just click whatever you like, and then this will be set in here. Or you can just decide what you want to have from this drop-down menu here. So nothing special about that. But keep in mind, those two are connected. So the IA grab here is this IA grab, and we can define what we want to have set as our triggers. And we can also do that with this rolling part. So that's just how we can actually make sure this input action is called correctly. This input mapping context is then used inside we have to go back to content, living room, blueprints, inside our living room player controller. And you can see the first thing which happens here is that we decide what should our enhanced input local player subsystem look like. And I just added the IMC underlined living room, which I just showed you. And that's our input mapping context, which we defined previously. We also have IMC weapons and IMC default. That would be the default part for our first person character. But I just wanted to have the living room inside here. And that's how you can change it. Simply click onto here and you can change the input mapping context. Now that we know how we can define input actions, we just have to find out how we can use them inside our code. And that's quite simple. Just use your right click here, and then we enter grab inside of here. And you can see we now have our enhanced action event grab. From there, we now want to do something, and this is creating a ray tracing towards our destination. To do so, let's create a function together. So we simply click onto the plus here. Then we call this find Dart via ray tracing. And we also have to add an input here. And this input is something very specific. I haven't shown you that before, but you cannot just define simple inputs such as Boolean variables, but you can also define blueprint inputs. So we just search for BP Dart, and you can see we have our object type BP Dart here. And then we have, when we hover over it, different options, such as the object reference, class reference, soft object reference, and soft class reference. In our case, we are interested in the class reference. Let's quickly select that, and I want to show you what it does for us. So first of all, compile again and rename your parameters. So in this case, we want it to be called Dart class to find. And then we recompile and save that. And now we can have a look at what this class instead of object value does for us now. So when we go to the event graph and we drag out our function here, which is currently doing nothing more than having an input and the start class to find, you can see we have now here our select class option. And this allows us to select any class that is a child class of the Dart blueprint. And as you can see inside our content drawer, if I go back to our darts, you can see we have this is our parent class and those two are our child classes. So we can now decide which child class we want to search for. And in our case, this is Dart Physics. So simply click onto that, combine those two here, and we are good to go by setting our Dart class to find inside our logic here. The next thing we always have to think about is what are the conditions, for example, in this case, when I want to grab something. And for us, this is when we don't have a dart in our hand, we just want to find a dart on a specific location. And that will be done using ray tracing. So let's go into the find dart via ray tracing function. And the first thing we have to do is adding a variable down here. So simply click onto that plus here. And now we have to select a new variable that should be called grabbed dart. And it should be a variable type of BP Dart, as you can see here. And in this case, simply search for BP Dart here. And then you can select the object reference in that case. And It should just be anything with type BP_Dart. That also includes child, but in this case, it's not a class to find, it's an object to find. So now we drag and drop this grab Dart into here. And now we can actually have a look at if it is valid or not. So we have to make sure that it is not null. So we have something in our hand, or we don't have something in our hand in our case. So we call is valid here. And you have two options now. You can pick the upper one or the lower one. In our case, I will go for the lower one because that is a macro. You don't have to do that now, but I just want to show you what it does instead. If we go for the function, you can see it just tells us whether or not it is valid. And in this case, we would also have to add a branch towards it to then actually get this macro up here. So in that case, the macro is just shorter and way simpler, so we don't use the isValid function. From there, we want to go on with isNotValid, and now we want to do a line trace by channel. So let's quickly do that. This is the function we want to have. And now we have something to think about. First of all, where is our starting point and where is our end point? Then we have a trace channel, what we want to check for. In our case, we could either use visibility or camera. In my case, I want to have visibility. Then we could decide if we want to trace complex, if we want to ignore some actors, and also if we want to draw a debug type. Let's quickly go for persistent here. And then we go on with defining an actual endpoint. And this endpoint should in our case be, let's say, we start from 0, 0, 0, and we end up with 200 in Z direction. So that will just shoot a ray from the bottom of our scene up to the top, so towards the ceiling. And let's quickly check how that looks like. So save and compile. Then we go into our scene and we start, and you can see this is how a ray trace actually looks like. We start from here and go up, and it interferes with the actual ceiling here. So that would be where our ray trace hit would then be counted on. You can see that here. So the out hit actually has a lot of values for us to offer. You can split that struct pin and you will see, holy moly, there's quite a bunch of stuff in there. You can get whether or not it was a blocking hit, it was an overlap, how long did it take, how far was the distance, what's the hit location, and so on and so forth. But what's interesting for us is the hit actor. So in this case, we now want to check if we hit an actor of the class, and that's the class we have to define. So we get our class here. That's the class of the thing we hit. And now we want to have our local variables down here, and that should be possible once I compile, that I have my Dart class to find in here. So I search for Dart class to find right here. And that's what we want to compare for. And if it's the same, we just hit a Dart with our ray tracing. And from there, we can now check whether this is true or not. So we simply go from here into a branch, and that's it for now. If it is true, we want to print a string. Let's go with that first. We want to print a string Dart. If not, we want to print another string. Just copy it and put in no Dart here. All right. So with that setting, we should be able now to have the exact same ray trace as before. So we go from the bottom to the top, and then we check whether we hit a Dart, and that should be the Dart class to find. So either the physics Dart or the projectile Dart. And if it's true, we just print out that we have hit a Dart. Otherwise, we have no Dart inside our ray tracing. So let's start. Let's right click and you can see it calls me no Dart. So we don't have a Dart in there. Let's check what we hit instead. So we go back in here. We go for the hit actor and we simply print this here. So simply connect those two. It will automatically create this get display name node for you. So now we can click and you can see we hit SM_floor. That was the first interference we had with our ray. Of course, it's not quite useful to trace something from the bottom of a scene to the top, but instead we want to trace something right where our eye is looking at. And that is our camera in our case. So let's quickly have a look how this looks like. So we go on to here. Let's get first of all rid of this get display name part here. We can also delete those print strings here. But instead, we want now to have a look where our camera is looking at. And that can be checked within the viewport. So that is our camera. You can see that. And this is determining what we can actually see with our eyes. We also have a first person mesh. Those are those two arms here. And the other parts are not interesting for us at the moment. But we want to start from the first person camera. And then we just want to shoot a ray like here to see what is in our way. To do so, we have to use a little bit of mathematics. It's not quite hard, but it's a little bit, let's say, uncommon at the first sight. So we use our first person camera and we get our world location. So we just drag and drop it here and then we call get world location. With this get world location, we just connect the starting point because we want to start at our camera. And now let's move that a little bit back. And now the part becomes a little bit more interesting to determine how we can actually find out where we want to look at. And the first person camera has different type of vectors for us. You can see we have the get forward vector, we have the get right vector, and the get up vector. So imagine I am the camera. So my forward vector would look like this. I would just look exactly at you. My up vector would be then something like this. So it would just go straight up. And the other part which we have is the right vector here. So the right vector would be something like into this direction. I don't know where this would point at, but those are the three options we can get. You might wonder now, how about the left vector and the down vector and so on? But that's not necessary because, when I have the up vector, I can just use times -1 direction and I will get the down vector. Same for the right vector. I only need the right vector because I can just multiply it with -1 and I will have my left vector. That's why there are only those three options. In our case, we want to have the get forward vector. So we just pick that. And now we want to have the forward vector added to our world location. So we just take a plus here. We call add. And now we want to add those two vectors. So this vector and this vector. And now we combine it here. And now there's something interesting happening. When I start to see now, and I right click, you can see there's nothing shown anymore. That's not actually true. When I move back a little, you can see there is this very, very small ray showing up. And that's what we created by our line trace. The big problem which we have is, how does the forward vector actually look? And I can show that to you. So let's go we just print here. You don't have to do that. It's just a demonstration. And then we go with the get forward vector. I will just drag and drop that somewhere around here. And let's start again. And you can see this is my forward vector. So it's just some very, very short vector, not even above 1. But instead, it is somewhere around 1, at least in one direction. And that's how our forward vector looks like. So that's the direction we're currently facing. Now we want to change this. And to do so, first of all, let's get rid of those two. Right? Let's just combine those two again. And you've seen the forward vector is just some value smaller than 1 in each direction. And of course, if we add some very small to our world location, that won't be useful for us. But instead, we want to define a grabbing range. So how far can I reach into the direction I'm currently looking? And to do so, we simply add a variable down here. We just call this variable grab range. And now you can see we have to recompile the blueprint to actually define a default value. So in this case, we go with compile and save, and we set the grab range to 200. And now we compile and save again to just make sure the changes actually worked. The next part, which is relevant for us, is then to multiply this grab range. So simply get the grab range and drag from the get forward vector. Then search for times, multiply. And now you can see we can just multiply two vectors, right? But that's actually not the case. If we hover over here and we right click here, we can set it to float single precision. And now we can just multiply a float together with a vector. Let's put it somewhere around here. Connect those two instead of the only plus here. And now we should be able to reach a little bit further. So let's go back to our scene. And now you can see we already have a ray which reaches quite far out. And in our case, if we now shoot at the darts here, you can see this is how the ray actually looks like. And it's drawn from the position we were standing at towards the dart with the length of 200. Now that we are able to ray trace from our camera's perspective, which we just created here, we still have to finish this function here. Because what we haven't changed yet is that we set our grab dart to the component we hit here once we have found out that our dart class defined matches the class of our hit actor. So to do that, we just drag from our hit actor here and call BP underline dart because we want to cast it to a dart class. Now we just connect those two. And from there, we then want to set our grab dart. So simply pick it from the variables down here, drag and drop it in here, call set grab dart, and then we can go on with the combination of those two. I won't do that yet because I want to show you that it doesn't work like this before because we have an actor object reference and our grab dart is some variable type of BP dart. That's why we can only use the casted version here, and that's why we have to use that cast here. Let me quickly move that up to go on. And from there, we now also have to return our hit component here because we have to work with that later on when we actually use the physics handle. All right, let's simply call a return node here. So we just drag and drop. We call add return node and we connect the out component off here with the return node up here. So simply take your component from there to there and just release your mouse. So you should be able to have now a connection and an output. The last thing we need to do is to rename that output because, I mean, hit component or out hit component is not pretty useful. So we simply change that to hit component and now everything should be fine in our function. Let's quickly wrap it up. So when we don't have a dart in our hand, we do a line trace from our camera's perspective to a certain location. So for example, 200 units into the direction where our camera is currently facing at. And if we then hit something which has the dart class to find class, so we can specify that in here by changing this, then we are able to cast it to a dart and that will always go through here, won't fail at all because we can ensure with that it is a dart class. And from there, we then call our grab dart now as this actor. And we also retrieve our hit component, which will be the collider we just hit with our ray to then work later on with it in the next function. Next thing we're going to do is now actually checking first of all that our hit component is valid and our grab dart is valid. So just in case we missed something, we go here and put our grab dart in here, then we call is valid. And we combine the execute pin. Then we also have our hit component. We also drag out from here and call is valid. And here we go. That's just how we do it. So now we check if our grab dart is valid and our hit component is valid. And from here, we have to get a specific component of our grab dart. And we want to have the collider. So simply drag out from here, call get collider, and then we have our collider in here. And for this collider, we want to set now our constraint mode. And this constraint mode is something I have to explain, I guess. So first of all, let's make it a little bit more nice looking. All right, compile and save. And now when I go onto the Dart here, you can see I actually have one of the darts here. Now if I go down a little, I have the collider inside the Dart blueprint. So let's go onto the collider. And you can see inside the constraints, I locked X, Y, and Z direction just to ensure that they can't move anywhere before we pick them up. So if I would disable that, physics, because I simulate the physics, would come into place and they would just fall off the dartboard, and that's not what we want. So that's why we have to enable the constraint mode here to none, so we can actually move them around. Then we want for the collider to enable our gravity, so enable gravity, set enable gravity, right? And gravity enabled should be set to true, because we now want to have them moving around. And the next part we want to have for our collider is that we want to set the collision enabled to some different mode. And that is set collision enabled. And this new type of collision is physics only, so no Curie collision, which means that we have only physics-based collision activated. So one more thing we don't know. This whole section is quite tricky, but first of all, let's finish that up first before I explain it. Then the next part we want to have is that we go with our hit component. So the only thing which we can hit is actually the collider of a dart. And let's go with this hit component. And first of all, call grab component. Okay, that's not working because that's not part of the component itself, but of this physics handle here. So let's quickly drag and drop that in here. And with that physics handle, we can now call grab component at location with rotation. And we simply add those two. We don't need a bow name. We don't need a specific component yet, but we need a location and a rotation. And that is part of this hit component, which I just dragged out from here. So first of all, this is the component we want to grab. Let's move that down a little. All right. And from there, we want to have the world transform. So we get our world transform. You can see that here. That is where our actual component is located. And from there, we just want to use the location and the rotation. So that's the position we want to grab from. And that's exactly where our dart is located. Now we have a whole bunch of stuff to explain. So first of all, the constraint mode, I already explained that, I think. It is part of the physics. And if you enable the constraint mode or set it to some specific plane, you will only be able to move the object in a specific direction. Since we don't want it to fall from our dartboard, that is set to disabled or to everything locked at the beginning. And now we set it to none to actually be able to move it around. Then we enable the gravity because otherwise they just would fall down, and that's not what we want. And now we set our collision enabled. And this collision enabled has different options. So we have no collision, Curie only, physics only, collision enabled, so Curie and physics, probe only, so contact data, but no Curie or physics collision, and Curie and probe. So how to explain that the best way? Let's say it like this. Curie would only check for collision that is not physics-based. And that is quite a difficult thing to explain, because if you have a collider, you want to set him to enable collision. Sometimes, for example, if you have the collider for the dartboard, you don't want him to be able to set a physics collision because you don't want to enable physics there. Otherwise, this whole dartboard would drop down unless you, of course, lock the constraints there. Then you have the physics only, so no Curie collision. That would only be everything that is based on physics. Then we have collision enabled Curie and physics, so it would not just be the objects where physics are enabled, but also the objects where physics are not enabled, so you would collide with everything. Probe only would just give you contact data, so what did you hit? And Curie and probe would then give you the Curie collision, so everything that is not physics-based, and the contact data, but no physics collision. So quite a hard thing to get into, right? Let's have a look at our darts, and maybe I can explain it there a little bit better. So if we go into our full blueprint editor again and go to the collider, that's the relevant part for us, you can see we can simulate the physics. And if this is the case, we only have the option to, inside our living room character, use physics only, or collision enabled where Curie and physics. So everything where physics is enabled, we could actually collide with this object. In the dart projectile, for example, I haven't enabled the physics for the collider, so you see there is no tick inside of here. But instead, I used a collision-enabled Curie and physics to detect collisions. And that is quite difficult to explain very detailed, but the thing is, our darts work very differently. One is only physics-based, so it would only interfere with physics objects, and the other one is not physics-based, so we would use Curie for that. And that's what we can set in here. Then we have our physics handle. And this physics handle is a component you can just add by clicking onto here and then searching for physics handle. And then you have physics constraint, handle, and thruster. But in our case, we have the physics handle. And this physics handle allows us to pick something up and move around with our character. So it's then part of our character. You can select the constraints here. You can set linear damping, linear stiffness, and so on. You can also activate this thing automatically, but it's just something where you can grab a component at a location with a certain rotation. Now that we're able to grab a component at a specific location, we have to actually be able to move it, of course. And that is something why I marked this red here. So we use our event tick for that. So simply right click, go for event tick. And now we first of all check if our grab dart is valid. So we get our grab dart, check if it's valid. It's valid. It's not late, but valid. All right. And if it is valid, then we want to take our physics handle and set the target location and rotation to the direction our billboard is facing. And here we have another keyword. What is a billboard? So if we go to the viewport, you can see this little dino thing in here. That's the part of the billboard. What happens now if I move around inside my viewport here? You can see the billboard always faces my direction. So in this case, that's just something which I can use to determine the dart to always face the direction I'm looking at. And that's what we do inside the set target location and rotation here. So we get our billboard and get our world transform for that. So get world transform. And from there, we just split the struct pin and take our location and rotation out of there. So what happens now? Let's quickly get rid of this event tick so I can show you what's happening. We are now able to move towards the dartboard. And when we now get this thing, you can see it just falls down, right? We haven't picked it up, but it falls through the ground. You can see And that's exactly why I enabled the constraints there, so it doesn't float like that around, but instead is set at a position. If we now actually use the event tick, where we have our grab dart and set it to the position of the billboard, look what happens now. When I go here and I pick the dart up, you can see I can move it around. And I already set the collision as I need to, because you can see the dart is now just wiggling around because it is colliding with something. And that's the big problem of physics. So if you have a physics-based collision, you can get this thing actually stuck within something or flying around as you see here. And that's not what we want, right? So that's the big problem with the physics aspect. But we are now able to drag around a dart and it will move wherever we go, maybe colliding with something which we don't want at the moment. But that's the best we can do when we use physics to actually have our physics handle being used inside of here. I know it's quite a bunch of stuff to get into physics and collision, and that's why I told you it was taking for me also like 32 hours, I think it was at the end, to actually get that collision done correctly. And that is the part why I want to show you how we can now throw the dart around. So as you might already expect, we now take our enhanced input action, but this time not grabbing, but throwing, and we go with the IA throw here. And this throw has first of all to check for our grab dart. Then we check if our grab dart is valid. So if we just hit the left mouse button, for example, it should not just be thrown away unless we have a dart inside of our hand. So if it is valid, we want to do it only once, do once. And what do we want to do once? We want to check if our grab dart has a class. So we just get our class here. That is equal to our class, which we just selected. So we go for BP dart physics here. Okay, let's go with physics here. That also doesn't work. Oh, there it was. Okay, I saw it. Dart. Here we have our dart physics. And now we have the actual test here. And we check if this is true. So we just go into a branch. So if our grab dart is from type dart physics, which will be relevant later on, we will go on here. Otherwise, when it is false, we want to go back and reset this to once so we can try again. And for that, we just move this up here a little so we can actually have a loop back to the do once and reset it so we can just click again. Otherwise, if this is true here, we want to release our component from the physics handle. So let's go with release from physics handle. And now from this physics handle, we release our component. You can see we can just call release component here. And with that, we make sure it's no longer part of our physics handle. Now we want to make sure that our grab dart and actually the collider of our grab dart has the right collision enabled. Because we set it to physics only before, now we want to set it to collision enabled. So we just call collision enabled, right? Set collision enabled, and we want to set it to the collision type of, we want to have all collisions, so Curie and physics, to be enabled. From there, we have to set our linear damping for the collider. And what is the linear damping about? So if we go with the linear damping, it is just how rapidly it can move forward and backward. And we want to set this damping to 0.01 so it can fly quite fast. And from there, we now want to have an impulse being added, and that's something you might know from other game engines such as Unity and so on. So we just call from the collider add impulse, and this impulse should be from the position of our first person camera. So we get our forward vector, get forward vector. And from there, we could already add the impulse, but it wouldn't be very strong. So, you know, the forward vector is something less than 1, and it would just drop our dart instead of throwing it. Instead, we want to also set a throw power. So to do so, we just go to the variables down here and add a new variable, which is called throw power. And we recompile the blueprint, and I figured out that 2500 in that case is a very good default value down here. So let's go with that. We go with get throw power, and then we multiply those two. We now know how we can actually multiply a vector and a float. So simply change that to float. And now you can actually add the impulse with the set throw power. And then we have to make sure that our grab dart is resetted to none because we don't have a grab dart anymore. And from there, we just want to make sure that we can throw again. So we go back to here. Just add something like this. All right. And then we can actually reset all of that and call throw again once we have a grab dart in our hand. So let's quickly do a recap about that. What is happening with the throwing party? So we have our grab dart, and if it is valid, we first of all do this once. So we check once if our grab dart has the class BP Dart Physics. If it's not the case, we just reset to do it once more once we clicked. Otherwise, if we have the Dart Physics class here, we release our component from the physics handle, which would just drop it. But at the same time, we go with the grab dart and there the component of the collider and set the collision enable to Curian physics so we can collide with everything. And then set our linear damping so it can fly very, very fast and is not like stuttering in front of us. And then we add an impulse to this position. And this position is our first person camera forward vector, so where I'm currently facing at. And I multiply that by my throw power, which is 2500. So it will fly with 2500, whatever this unit means, into the direction where I'm currently looking at. And then we just have to make sure that we reset our grab dart. So our grab dart is now no longer a grab dart. Of course, we don't have anything in our hand anymore. And thus we want to check again when we press the next time the throwing input action if we have a grab dart of BP Dart Physics, and then we just continue with this part. All right, let's check that very quickly. So we just start. Now if I go here, you can see I'm now able to grab the dart. And when I now press the left click, it will just fly and collide with whatever I throw it to. It will also collide with the wall, you can see. And this is just how we can grab a dart, move around, and then throw it. So the last thing we have to do is to actually make it stuck once we hit the not the chessboard, but the dartboard. Now that we implemented the whole throwing logic and grabbing logic, we just have to make sure that the dart gets stuck once it hits the dartboard. And to do so, we go into the content drawer, content, interactive media, darts, blueprints, and then we go onto Dart Physics. And from there, we have our components in the upper left corner. So we go onto Collider. And as you might already know or remember correctly from the chess project, if we scroll down completely here, we get our events. And you can see we have the on component hit event here, on released, on clicked, and so on. You also know now what on released means. So that would be just we got released from a physics handle. But in our case, we want to have on component hit. So simply click onto the plus here. And from there, you just have your event added to your blueprint. Now we want to check what we actually hit. And what we hit is inside of here. So our other actor and other component. In this case, we just want to check for the actor. And we want to cast this actor and make sure that it's part of Dart cabinet. So it should be a Dart cabinet. And if this is the case, we just go on here. And for that, we have to drag out our collider here. We take this collider, and for the collider, we set the linear damping. You now also know what this does. So it won't move at all anymore once we put a ridiculously high amount in here. So for example, let's put that in. Doesn't matter how many zeros you put in there, but just make sure it's more than 4 at least. And now we also set our angular damping. So let's call angular damping. We want to set our angular damping, and we also want to set that to a ridiculously high amount. And why is this the case? That's quite easy to explain. We want it to be completely stuck in position. So it should be damped like crazy. Once it hits the Dart cabinet, it should be 0 speed anymore. So it should just be at the position. So that's the linear damping. That's the forward moving speed. And the angular damping means the rotation it has from there. And it should have no rotation at all anymore. It should just be stuck at that position where it just got thrown to. And to make sure that we know what the Dart cabinet actually got hit by, we also want to print a very short string here. And we will just print out hit by physics Dart. We will also do that in the next lecture for the projectile dart, but that is our whole logic. So let's quickly wrap it up again. We have our hit. Once we hit something with our collider, we check for the actor we hit. If the actor is actually of type Dart cabinet, then we go on and set our collider's linear damping to a ridiculously high amount and the angular damping also to a ridiculously high amount. And that's just because we want it to be, let's say, not moving at all anymore. And then we call hit by physics Dart, so we know what actually hit the dartboard. So if we go back to our scene now, I can move around, of course, and now I can also pick it up. You already know that. But what you don't know is once I throw it against the wall, of course, it just goes wild and then it lays on the ground. But now I can pick it up again and look what happens once I hit the dartboard. Bam! We now have our collision perfectly matched with the actual point the dart hit the dart cabinet on. And we can do that with all of those darts, and we can also repick them up because we set the collision before correctly. And now we have a fully working physics darts. Yep, that was just the ventilator above me. So that is also something you have to always make sure that nothing is in your way. But then it will just look like this, and that's exactly what we want. We are now able to play darts without a score, of course. I know this whole physics part is quite a huge step compared to where we've been before, but I just want to quickly wrap it up again so you will actually have a chance to understand what we did here. So first of all, what we do is we call our enhanced input action IA grab and find a dart via ray tracing. You now know how that works. We just shoot a ray in the direction we're currently looking at, and thus we can check whether we hit a dart or not. And if this is the case, the grab dart here will be valid. So we go on here, and we also have our hit component, which we have to check for. So if we actually hit a collider of a dart and it is valid, we have a dart in our hand now. Then we go on and take this grab dart collider and set the constraint mode to none. That's just part of what I told you already. I just had to constrain the movement axis of the dart because it would just fall down when I enable gravity. So I just disabled gravity, which we re-enable here. And I also set a constraint, which we also set to none here, so it can now move freely. Then we also set the collision enabled to physics only. It was Curie only before, so it would not interact with the Dart cabinet in this case. And then we get our components transform. So that is where our Dart is actually located, or the collider is actually located. And with that, we just grab the component at its location and rotation and add it to our physics handle, which allows us to grab some objects and move them around freely. To be able to do so, we have to use the event tick. And of course, we only want to use the physics handle when we have a Dart in our hand. And then we just want to set the target location and rotation of that physics handle to the location of our billboard. And that is just to show you once more, when I move around inside the scene, the billboard will always face the direction I'm currently looking at. And from the camera perspective, we can just ensure that this is always the direction we want to throw the Dart at. Well, from there, we now are able to move our Dart around, like we walk around and the Dart will always be at a specific position. And from there, we can now throw it. So once we have a grab Dart, we first of all check once if we have a grab Dart of class Dart physics. And if this is the case, we just release our component, and that will be our Dart falling to the ground, basically. From there, we also check if we don't have that, we go back and make sure we can actually check again once we click the throw. So just to make sure that we are not having any problems once we want to throw something again, we are able to check so. Then when the component is released and everything is working, we go for our collider again. And this collider has then collision enabled, and it's set to Curie and physics, so it can actually hit the dartboard. And from there, we set our linear damping to 0.01, so it can very quickly move forward. And then we add an impulse at the location of our first-person camera, so where we just want to shoot from, with a certain throw power, which in our case is 2500. And that will add an impulse, which just lets the Dart being thrown against whatever it hits next. And then we just make sure we don't have a Dart in our hand anymore, so we set our grab Dart to 0, or to null actually, and then we go back into here and make sure once we press throw again, we can check if our grab Dart is of class Dart physics. And if this is the case, everything goes on again and we can just throw it again. So that's why we can pick up darts and why we can throw them and pick them up later on again. That's the whole logic in here. And I can tell you it is quite tricky to set all of this up correctly, as you can imagine maybe, because you have to make sure that everything, the collision has to be right, the damping has to be right, the gravity has to be enabled so you can actually throw it so it makes the curve and so on. And that's just how you can set it up in here. Inside the Dart physics then, we are able to call what should happen once we hit something. So in our case, if we hit something with our collider, we check if our other actor, so the actor we hit, is of class Dart cabinet. If this is the case, we set the linear damping and angular damping to a ridiculously high amount to make the Dart stuck there, and then being able to actually pick it up again and throw again. And then we are back in here, so we just find our Dart via Raytracing, and we just set the constraint mode to none, so we can actually pick it up from the Dart cabinet again. Yeah, that's the whole logic implemented, and I hope you understand now a little bit better how physics work in Unreal Engine and that it can be quite tricky to set them by hand. Normally, you don't need to use that, but in our case, since we have a very closely related collision to be detected, so we have to make sure it actually is the exact location where the Dart hits. Let's quickly show that again. Because if I just take the Dart and throw it here, A millimeter can make the difference between hitting the 10 and the 15, and we have to ensure that everything is just being detected correctly. Let's quickly check what our current project progress looks like. You can see we've finished lecture 9 now, so you know now how you can handle a Dart physics-based. And next time we will have a look at the projectile-based collision. And don't worry, you will get into how you can set up collisions. That's quite a tricky one, I know, but you will get the hang of it. Well then, I hope you still feel confident you're able to manage Unreal Engine. I can assure you that is a very hard part, which I just showed you, but making collisions work together with physics is very, very tricky. And thus, I want to show you another option for the next time. And that will be part of the next lecture where we will actually fake everything you've seen and just use a projectile instead to be spawned and actually be thrown as a dart. It also includes some difficult setup, but it is not as hard to fix as physics-based parts because you've seen I can glitch through something, I can collide with something I don't want to, and that's just annoying as hell, and you can't get rid of all of those flaws, but with projectile-based movement, that's way easy. With that being said, thank you for listening. I wish you a very good day and see you soon.